So now in this video we have an op-amp voltage ramp here. That's that circuitry there. It's being controlled, though, including this resistor, it's being controlled by the output of a 555 timer when the output starts going high and low. The main thing is, though, is that you can see the LED starts off dark, gets brighter and brighter until it gets bright. And then it's bright for a while, and it gets darker and darker and darker until it is off. The voltage that is coming out of the output is rising steadily and lowering steadily based on the 555 timer. So now I got my pocket oscilloscope here. The reference voltage for the probe is the negative supply there, 0 volts, and then we got the probe right there. So it's got a little hook that you can slide out there and hook it to things. I like to hook it to the jumper. Make sure the jumper doesn't touch any supply voltage though, or something. And that should not either. I had that pegged into the board. But in case, we have the same setup for the other side over there. One probe is one color, and you can tell that's the 555 sudden voltage change right there. And it's getting closer to 12 volts. Looks like 11 volts. Each square here is 2 volts. 2 volts per division, because we're working with 12 volts. And but yeah, you can see that ramp, but that ramp is going really quick. So what we're gonna do is pluck the 1 million ohm timing resistor right there and put a 2 million ohm resistor in its place. So the ramp will take about twice as long to go high and low. I tried a higher value resistors, but they kind of messed up the waveform. So we don't want it to take so long to go high or low that we don't level off in this particular circuit. I think I can make an improved circuit where we can kind of center things, and then it will keep bouncing up and down in a triangle wave pattern. But there you can see, when the output goes low from the 555 timer, then we start getting that charge. The LED gets brighter. Its output starts going higher because it's wired as a voltage follower. And then when the output drops low, then the voltage rises. And then when the output jumps up, it takes a little bit, but then the voltage starts going down. So the reason why we got a little bit of a delay is because we're getting from peak to peak. But if I try to adjust the timing the way we have it now, either I'll be hitting on the bottom for long periods of time and then bouncing up and down for short periods of time, or I'll sit up on top for long periods of time before going down a little bit and then coming back up a little bit. So the way I have this wired now, we're kind of set with this limitation at the moment. So now let's take a closer look at the schematic and the physical circuit. So yeah, first off we have an op-amp, and the way we wire up, we set half the supply voltage at the non-inverting input. Basic op-amp stuff. 10K resistors is what I'm using. And we got that 12 volts powering this. Now, when the output is high here, then that raises this voltage. And when this voltage is higher than this one, then it sets the output low. This one would be lower. And so if we got higher over here, you can see that current path right there. Now, when this raises the voltage far enough, so we're looking at up there, it it levels off, raises it enough, then this will drop down, and we'll have a lower voltage at the inverting input than we have at the non-inverting input. So when that's lower, this one is higher. That sets the output high. Not completely high. It's actually, we saw the voltage, how it's changing the voltage. It's lowering it and raising it. So just be aware of that. But yeah, when this one is lower, that one's higher. That makes this voltage higher than what we got there. And the capacitor starts charging in that direction right there. When you think of positive towards negative. So the resistor is going to set, the current speed, and the voltage must be a voltage difference between what the output is and the inverting input in relationship to the non-inverting input. So yeah, I don't have a great explanation for how that works out, but we saw the waveform. And of course, this is a 555 timer wired in astable mode right there. So the capacitor charges when the output is high. Again, it's not going to get the full 12 volts. It looks like we got 11 volts because each division on the oscilloscope was 2 volts. So if it went up 5.5 squares, that would be 11 volts. Hopefully that makes sense. So that's while the capacitor charges. None of these are letting current through while the capacitor charges. It gets to 2/3 supply voltage, as seen by pin 6, and then it discharges through pin 7 right there. So it's going to take slightly longer to charge than discharge. You can adjust the timing all kinds of ways. Basic 555 timer stuff. But yeah, it discharges until pin 2 sees 1/3 of the supply voltage. Then it stops discharging. This turns off and it starts charging again. The cycle just keeps repeating. So, you know, all basic stuff we've covered many times and are covered in many videos by many people. Astable 555 timer. The ramp, the op amp ramp is not a real common one. You'll have a little harder time finding people explain it, but some people will really learn this circuit in great detail and explain it in great detail. I don't have an interest in going that far into it. I got the circuit to work basically how I wanted so far, so I'm going to finish it at that. But yeah, there you can see the capacitor at the output to the inverting input. So that's you know, negative feedback in a way, which is used when you want oscillations. You want things to keep going back and forth when you have an op amp. And so positive, or the plus input, non-inverting input, right there we got our voltage divider, equal value. And that jumper is just coming from the output to the load, just to set it off to the side. We could have worked our way up here and gone to ground or something, but I decided to push it over there for whatever reason. 1000 ohm resistor because we're working with 12 volts to protect things. And of course you always have to power your integrated circuits, whether or not they show them on the power supply. Pin 4 is the reset pin. If that gets a low input, close to 0 volts, it will hold the output low no matter what we do. So we put to the positive supply, then it just doesn't do anything. It's just waiting for a low input. But yeah, that's about it. All kinds of ways we could modify this. May not work out as well though. So, you know, you got to take that into consideration. But in any case, that is to the negative supply, by the way, right there, the negative side of the capacitor. This one is polarized, has to be put in the right way. That is not a polarized capacitor. You can put it in either direction. The non-polarized ones tend to come in smaller values, and the larger ones tend to be polarized. So, you know, unfortunately, I couldn't use a larger capacitor here. If I did, I could use lower value current setting resistors, and you know, then we'd have more flexibility. But for now, this is what it is. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.